Now I will talk about special relativity and the twin paradox. Special relativity is an explanation of how speed affects mass, time and space. As an object approaches the speed of light, the mass of the object becomes infinite, and so does the energy required to move it. This means that it is impossible for any matter to go faster the speed of light, or even reach the speed of light. Now I will talk about the twin paradox. The first twin flies into space at a very high speed, for example 240,000 kilometers per second, and returns to Earth while the second remains on Earth. According to the theory of special relativity, movement at high speed slows down the flow of time. So the brother who went on a journey in space will return to Earth 10 years younger than his brother who stayed on Earth. Now I will describe the paradox in detail. One twin remains on Earth while his brother moves away in a spaceship at a very high speed, close to the speed of light. At some point, the brother turns around and returns to Earth. According to the theory of relativity, the journey in the spaceship will take less time than on Earth, which will lead to the brother in the spaceship returning younger than the brother left on Earth. For example, suppose the journey is to the star Epsilon in Eridanos, which is about 10 light years away from the solar system. And the speed of the spacecraft is 80% of the speed of light, that is to say 240,000 kilometers per second. According to the twin left on Earth, the round trip as measured on Earth is T naught equals to 2 times L naught divided by V equals to 2 times 10 divided by 0.8 equals to 25 years. So the brother in the spaceship travels from Earth to the star Epsilon, that is 10 light years far away from Earth. So, and he does the journey back and forth, so in total it travels 2 times the distance of 10 light years. In total is 20 light years. Total way is 20 light years, and it does it in speed of 80% of the speed of light, that is 240,000 kilometers per second. So total way divided by the speed is the total time, and the total time is 25 years. So from the point of view of the brother that is on Earth, the total time that is passed on Earth is 25 years. And according to the Lorentz transformation, the time measured by the twin in the spacecraft is T spacecraft equals to T naught times root of 1 minus v squared divided by c squared equals to 25 times root of 1 minus 0.8 squared equals to 15 years. So the total time that it will take to the brother in the spaceship to do all the journey is 15 years only, that is 25 years t naught times root of 1 minus v squared divided by c squared. So because of the fact that the twin brother that is in the spaceship travels at very high speed, then the rate of time flow in the spaceship will be slower than the time flow on Earth. This phenomenon is called time dilation or time lengthening. So, from the point of view of the brother that is on Earth, he is on rest, and his brother on the spaceship travels at very high speed on the space towards the star epsilon. So in this situation there will occur a phenomenon that called time dilation. So the rate of time flow in the spaceship will be slower than the time flow on Earth. So in total it will take the brother in the spaceship to do all the journey, because of time dilation or time lengthening, all the journey will be only 15 years, 10 years less than the time that is passed on Earth, because of time lengthening or time dilation. The rate of time that is passed, the rate of time flow on the spaceship is less than the rate of time flow on Earth, because the spaceship is moving at very high speed. That is the reason that there will be time dilation in the spaceship, and the total journey will be only 15 years. According to the twin in the spacecraft, he is at rest, while the Earth on which his twin brother is and the star epsilon are moving across it at speed of 80% of the speed of light. As a result, the distance between them shrinks according to the Lorentz transformation, so the distance it must travel is L spacecraft equals to L naught times root of 1 minus v squared divided by c squared equals to 10 times root of 1 minus 0.8 squared equals to 6 light years. So when someone or something travels at very high speed towards you, there will be a contraction of distance between you and the object that travels at very high speed, according to special relativity. So there will be a contraction of distance between the spacecraft and the star Eridanus. So according to the twin of the spaceship, he is at rest and the star Epsilon is moving towards him at very high speed, and that is the reason that there will be a contraction of distance between him and the star Eridanus. That is according to special relativity. So the distance between the brother in the spaceship and the star Epsilon will be no more 10 light years, but it will be shrink to 6 light years because of contraction of distance, according to special relativity. So then we must calculate again the total distance, that the total time that it will be passed on the spaceship, because we see that the distance between the spaceship and the star Epsilon shrink to 6 light years. So the total time that it will take the spaceship to do all the journey is T spacecraft equals to 2 times L spacecraft divided by V equals to 2 times 6 divided by 0.8 equals to 15 years. So because the distance between the brother that is on the spaceship and the star Epsilon shrinked or contracted to 6 light years only, so the total distance back and forth that it must travel is 12 light years. So the total distance divided by the speed will give us the total time. So 12 light years divided by 240,000 kilometers per second, or 80% of the speed of light, will give us 15 years. So the total journey will be 15 years only, according to the brother that is on the spaceship, because of contraction of distance. As I have already said, the brother in the spaceship sees himself at rest, and the star Epsilon is moving towards him at very high speed. So, according to special relativity, there will be a phenomenon that is called the contraction of distance. And the distance between the brother that is on the spaceship and the star Epsilon will be only 6 light years. So the total distance back and forth is 12 light years, and in the speed of 80% of the speed of light is total way divided by the speed is the total time that it will take him, only 15 years. Okay? Because of contraction of time from the point of view of the brother that is on the spaceship. Therefore, but of course it is just as the twin who remained on Earth had calculated 15 years only. Yes, therefore the two twins effectively agree that the twin in the spaceship will be younger when they meet again. In terms of the twin that remains on Earth due to the effect of time lengthening, and in terms of his traveling twin due to the contraction of distance. Okay, thank you very much.